Hello, Algebra 2 students. I appreciate you finding time to take care of your notes. Today we're continuing on with the discussion of division of polynomials by looking at a second method, which is referred to as synthetic division. So if you would please copy down the title, Dividing Polynomials by Synthetic Division. Our objective for today is the student will learn to divide polynomials by the synthetic division method. As always, press pause anytime you need more time to copy stuff down, then hit play when you are ready to move on. Now, synthetic division is a completely different method. It utilizes some of the same concepts that we had during the long division method. However, a lot of people like the synthetic division method when they can use it because it does eliminate a lot of the kind of clutter and formality that long division brings to the table. Okay, now synthetic division, as we said, is another format for us to divide two polynomials. Okay. However, synthetic division does not work for division of all polynomials. Actually, our problem has to be formatted in a certain way before we can use synthetic. In order to use synthetic division, the divisor must be of the format of simply x plus or minus c. Okay, and obviously c is our constant, our x to the 0 term, just some integer, a number. Okay, and that also means that your x, as you can see there, must have a coefficient of 1 and must be to the first power. So if anything about your divisor does not meet that format, then synthetic division is not an option and you will have to use the long division method. Okay, so let's take a look here. Okay. We're going to start off with an example. Here we have 2x squared plus 3x minus 5, and that is being divided by x plus 1. Now remember, the 2x squared plus 3x minus 5, that is what's being divided into. That's what we call our dividend, and x plus 1 is our divisor. Now we can use long division on this problem because we can use long division on division of any two polynomials. However, synthetic division is much shorter, a little bit easier if we can use it. Okay, so let's have a look. Is this a problem that is eligible to use synthetic division? We'll have a look at the divisor, x plus 1. Does it fit the format? Is your variable have a coefficient of 1 and an exponent of 1? Yes, all we have is just an x. And do we have just a number hanging on to the back of it, a constant? Yes, we do, positive 1. Okay, so good. Synthetic division is an option with this problem. Okay, so what we're going to do, the procedure, once you verify that you can actually use synthetic division, is to use only the coefficients of your dividend and list them from the largest power to the smallest power. Okay, so focusing only on the coefficients of the dividend, let's look and see what we have. Okay, our coefficient of our x squared is a 2. Our coefficient of our x to the first is a 3, and our coefficient of our x to the 0 is a 5. Okay, so we're basically just going to write those down on our paper with a little bit of space in between them. And then what we're going to do is we're going to look at the constant that is in the divisor. Okay, we are going to take the negative of the c term from the divisor, and we're going to place it out to the left of those coefficients in a little kind of half box bracket looking guy. I don't think it even has a particular name. Okay, we're just going to position him out there. Okay, so it's a negative 1 because in the divisor it was positive 1. So we're taking the negative of that 1 and we're writing it down as you see there. Okay, so now let's get to the math of it. From this problem, we recognize that we had the ability to use synthetic division, and we set up the synthetic division, and the only other thing to do on the setup is to drop down a line and then draw an underline. Okay, so we're going to need a line's worth of space in between the coefficients from the dividend and this line that we're drawing now. Okay. All right, so let's get to it. The first step that you do is simply bring down the first value. And I'm not sure how you're going to want to do this on your notes because there's going to be a lot of arrows and things popping in and out of the problem and little instructions out to the right. So you might want to, at the very least, copy down all of the instructions as they show up on the screen and maybe just adjust your problem. Or the example, adjust the example as the instructions come on. Okay, but the first step for any synthetic division is you're simply going to drop the first coefficient to down underneath that line that you drew. Okay, now the process of synthetic division is to bring things down, and then whatever gets brought down, we are going to multiply that times whatever number is out in the box. And whatever the result of that multiplication is, will get positioned underneath the next term over to the right, okay, in between that term, but in between that term and the line that you drew. Okay, so in this case, we're multiplying the 2 that we brought down times the -1 in the box, and that gives us a -2, so we're writing -2 underneath the 3. Okay, we've already brought the 2 down. We're not messing with it anymore. Now we're scooching over and we're messing with the 3. Okay, after that multiplication is done, the next procedure is to add these stacked terms that you just created. The 3 that came from the dividend and the -2 that you just got from the multiplication, we're adding them up. So of course 3 plus -2 is 1. Now, if you can get to this point, this is where the problem simply becomes repetitious. Every time we drop a number down and it gets underneath that line, then it multiplies times the number in the box, and the result of that multiplication pops in over underneath the next term over to the right. Okay, so in this case, the +1 that was the result of us adding the 3 and the -2 is going to multiply times the -1 in the box. That's going to give us a -1 result. So we write the -1 underneath the -5. And just like we did a moment ago, whenever we get those numbers stacked in there like that, then we add them up and we get a result. Okay, so in this case, the -5 plus the -1 is -6. Okay, once you get to the point where there are no additional coefficients going to the right, like we're at right now, okay, we are at a stopping point as far as the math is concerned. Okay, these values that you just arrived at are going to be the coefficients of the answer and the remainder. Okay. Now, the way that you read these coefficients is the guy over to the very right side, the -6, the very last term that you arrive at is going to be your remainder. As you move leftward from there, okay, that's going to be your x to the 0 term. Scooch over to the left again, that would be an x to the first term, and if you had more numbers to keep scooching left, that would be increasing the exponent of the variable each time. Okay, so what it means for this problem is this. Okay, we have a -6 as a remainder, and remember from our discussion of long division, our remainder goes in the numerator over the divisor. So -6 over x plus 1. Now as you move to the left from that -6, at the result of your synthetic division, okay, the +1 is our x to the 0 term, so there it is. And as you scooch to the left of it again, the 2 is our x to the first term. Since those are the only values we had at the result of the synthetic division, this is our answer. When we take 2x squared plus 3x minus 5 and divide it by x plus 1, it goes in 2x plus 1 times, okay, with a -6 remainder over x plus 1. Okay, now hopefully you find that to be not quite as complex as the long division method, but like any other thing where there's multiple steps, it's going to take us a little bit of practice before we're going to get used to it and feel better about it. Let's look at another problem. Okay. Now, just like with the long division method, we're not allowed to skip any missing variables. Okay, so we need to make sure that the terms are spaced properly. If you find a situation where terms are missing, then you must install zeros for coefficients of those missing terms. Okay, so the problem that we're looking at this time is x cubed minus 6 divided by x minus 2. First thing you want to do with synthetic division is ask yourself if the problem fits the synthetic division format. If it does not, then you cannot use it and you must use long division. Okay, so have a look at the divisor and let's see if it fits synthetic division's requirements. Okay, it is x minus 2. That is the synthetic division requirement. Our x has a coefficient of 1, okay, an exponent of 1, and then we have a constant hanging on to the back side of it, negative 2. Okay, so we can use synthetic division. All right. So, but the thing we have to watch out for on this one is our degree is 3. We have an x cubed term. However, we do not have an x squared term. We do not have an x to the first term. So those guys, every term underneath x cubed needs to be represented. And if this had been any other value at x to the 10th, that means x to the 10th is going to have to be represented, x to the 9th, x to the 8th, x to the 7th, and so on. Okay, so clearly on the dividend, we are missing the x squared and the x to the first terms. Okay, so when we set up our synthetic division problem, these places are going to need to be held by us in the problem. Okay, so let's set it up. We have an 1 coefficient for our x cubed. We do not have an x squared, so that is a 0 coefficient. We do not have an x to the first, so that is a 0 coefficient. And we do have an x to the 0 term, which was negative 6. So we write those coefficients out with a little bit of space in between them. And out in the box, this time we will have a positive 2. Why is it a positive 2? Because with synthetic division, we are looking for the negative of the c term. The divisor had a negative 2 in it, so it is a positive 2 out inside of the box. So this should be the setup that you are looking for. Okay. Now, after you've got the problem set up, let's get it going. First thing you do in synthetic division is bring down the first value. So that 1 coefficient gets to drop straight down. Once we bring a value down, that will multiply times the values in the box. So the positive 1 that we brought down multiplied by positive 2 is 2. We write this result underneath the next term over. Okay. Once we get numbers stacked above the line like that, the next step is to add them up. 0 plus 2 is positive 2. You probably ought to be able to finish it off from here if you watched the first one, first example. We got a number underneath the bar. That will multiply times the box. Positive 2 times positive 2 is positive 4. We write this next number down underneath the next term over, and we add them up. 0 plus 4, 4. Okay, we have another number underneath the bar. This multiplies times the box. 4 times 2 is 8. We write this down under the next term over, and we add them up. Okay. Once we get to the point where there are no more terms over to the right, then we are done. Okay, so keep in mind, these terms are from the right to left. The right is going to be our remainder. The next one to the left will be our x to the 0 term. Next one to the left will be x to the first. Next would be x squared. Sorry, I went the wrong direction. Okay, and so on. Okay, so it might be worth your time to get into the habit of writing this little notation down. Okay, where r is on the right side and then x to the 0, x to the first, x squared coming back to the left. Okay, that might help you keep it straight when it's time to write down the answer. And the answer obviously is we have 1x squared, we have 2x to the firsts, we have 4x to the zeros, and our remainder was 2 out of x minus 2. So when x cubed minus 6 is divided by x minus 2, it goes in x squared plus 2x plus 4 times, and then it got in 2 out of x minus 2 times. So it got in another fraction of a time. Okay. Hopefully after the discussions on long division, this is probably not nearly as bad for you. And it's not that synthetic division is so much easier, it's that getting a grasp of long division, seeing that process and following those steps, that actually makes synthetic division easier in our minds because we have a better understanding of how division works. We know how to repeat that process. It's the same process, it's just structured differently. Okay, so I have a couple of problems that I'd like you to try, and unlike the long division, I actually expect you to be able to give these a good shot. So here, let's copy these down. Okay, we have 2x squared minus 9x minus 10 needs to be divided by x minus 2. You'll want to look at it, check and make sure synthetic division is a good option for this problem, and then work it out. Another example that you have is this one. X to the fifth plus 2x cubed minus 3x squared plus 20, and that needs to be divided by x plus 1. Again, always double check to make sure synthetic division is a good option before you try to use it, and then if it is, work the problem. Okay, so those two examples, I expect you to get those worked out and bring them with you to class. I appreciate you finding time to do your notes, and we will see you in class.